Problem number 1 reads, if A, B, and C are all positive real numbers, which graph could represent the sketch of the graph of P of x equals negative A times A plus B times x squared minus 2cx plus c squared? The first thing I do is take a look at my 4 graphs, and I immediately recognize that my 4 graphs are all the graph of a cubic. Now, I'm going to take a look at my factor x plus b. If x plus b is a factor of this cubic, then that tells me I should be able to set that factor equal to 0 to solve for the 0, or to solve for a root where the graph will cross the x-axis. X plus b equals 0. Subtract b from each side. And I know that one location where this graph should cross the x-axis is located at negative b. I have now eliminated choices 2 and 4. Both choices 1 and 3 cross in the exact same roots, at the exact same zeros. They both cross at a 0 of negative b and of positive c. I'm now going to take a look at my lead coefficient, negative a. Negative a tells me that my correct result is going to be choice 1, I know this because a standard cubic with a positive lead coefficient would look like choice 3. I could graph any cubic to simply test what that a value does. Number 2. Which equation represents a parabola with a focus of 0, 4 and a directrix of y equals 2? So my method that I prefer is a modification of the distance formula. Distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. I'm now going to use the focus to substitute in to my equation. Now d ordinarily stands for distance. One of my tricks to help me remember this is that when I'm using the focus and directrix, my d also could stand for directrix. So I'm going to take my directrix of y equals 2 and I'm going to set it equal to 0 by subtracting 2 from each side. Now I can substitute in that directrix for the d. Y minus 2 equals the square root of x minus the x coordinate of my focus, 0. Y minus the y coordinate of my focus, 4. Now, this is a radical equation. My radical is isolated, so I can go ahead and square each side of the equation to eliminate the radical. Y minus 2 squared is y minus 2 times y minus 2. On the other side of the equation, the square root and the squaring cancel one another out. I'm left with x squared plus y minus 4 squared. Y minus 2 times y minus 2 leaves me with y squared minus 4y plus 4 equals x squared plus y minus 4 squared. Remember, that's a y minus 4 times a y minus 4. Y squared minus 8y plus 16. All I need to do now is get my equation into a form that will match one of my four choices. I'm going to start by subtracting y squared from each side. They both cancel. Negative 4y plus 4 equals x squared minus 8y plus 16. I'm now going to add 8y to each side, and at the same time I'm going to subtract the 4. 4y will equal x squared plus 12. Lastly, let's divide each side by 4. Y equals 1/4 x squared plus 3. And that matches choice number 4.